Hi everyone, today we will be talking about first problem from today's contest, because I wasn't able to solve more. I am sorry for this, but well, I think in the future better people will be doing hard. So yeah, in the future better people will do contests like this one for sure on this channel. So in the only problem we will be talking about today, we are given the definition of neck number. So the neck number is such a number, it's a number such that no two adjacent digits are the same. So for example, this is some neck number, but number 1001 is not a neck number because those two adjacent digits are the same. And we are given many test cases, and in each test case we are given one number k up to 10 to the power of 12, and we want to say what is the kth neck number. So kth number such that no two adjacent digits are the same. Right. Yeah. Okay. So how to solve it? First, think about how many there are neck numbers of length k. Right? This is so. How many choices we have for the first digit? 9, because it can be from 1 to 9. How many choices we have for the second digit? Well, we have 9 choices, because we can pick each digit from 0 to 9, but one of the digits was chosen before, and we can't pick those digits. So it will be from 0 to 9, but one of the digits will be excluded. Let's say that 4 will be excluded, or something. Right? And it's the same for each next digit. We can pick each one of the 10 digits, but not the previous one. So for each digit we have 9 possibilities. So we have 9 to the power of k neck numbers of length k. So now the problem is standard. It's some variation of digit dp. We want to first find the length of the kth we first want to find the length of the kth neck number. So how to do it? Well, what we'll be doing, we first assume that we first look how many there are neck numbers of length 1. There are 9 of them. Let's say that our k is equal to 13 of 27, 113 on the start. So we have 9 neck numbers of length 1. So what we see that we want to find the 113th neck number. So we see that it will have the greater length. So right now we are looking for the kth neck number of length at least 1. So we see that it's the same as we know we have 9 neck numbers of length 1. So we can say that it's the same as if we would look for the 113 minus 9th neck number of length at least 2. Right? So it's equal to 104. So now we only look for the neck numbers of length at least 2, and we want to find 104th of them. Okay, we do the same thing with 3. We are subtracting 81, right? Because and now we are looking for the 104 minus 81. We are looking for the 23rd neck number of length at least 3. We see that we have 9 to the power of 3, so 629, I think. 629 of this. So, well, we now know that our number has length 3. Right? Because there are more of this than k. So now we are doing the same, but constructing our answer from left to right. we are iterating over all possible first digits. So if our first digit is 1, then we have 81 possibilities, right? Because we have 1 and then 2 digits, so 81 possibilities. So we see that it's greater than 23. Great. So we know that our first digit is 1. Then we are iterating over our digits once again. We are trying 0. If 0 is here, then so we know that we have this 1 that we already know that we want to have here, then 0, and then we have something with 1 digit. So how many we have how many neck numbers have 1 digit? 9. So we see that we have 9 numbers such that they are 1, 0, and then something. But we want to find the 23rd number. So we are subtracting 9. Right? Now we know that we can't get 1 here. We need to get 2, because, well, otherwise it would be a neck number if it would have 1. So, here we have 23 minus 9 equal to 13. So now we know that it has to have 2 or more on this position. Well, once again, there are 9 such numbers such that they have 1, 2, and then something. So we have 14 minus 9. So with 2 we have like 9. So, well, 14 is still bigger, so we are subtracting, getting 5. And well, when we'll try 3, it will work, cause we have like 9 numbers with prefix 1, 3, and then something. So we want to find the 5th number with prefix 1, 3 and 1 digit added. So, well, I will spoil it for you, it's 136. Cause, well, we want to find the 5th number such that it has prefix 1, 3 and then something. So it will be 130, 131, 132. 133 is not good, so 134 and 135. Oh, I'm sorry, it's 135. Yeah. So our answer is 135. And that's basically how you do it. I will show you also my code to this problem. Here is my failed attempt at B. So basically, what I am doing, I'm keeping my current length. I'm sorry for using Polish answer. I forgot that I will be Polish names. I forgot that I will be showing it to you. Wait. Also, let me make my code bigger. Okay, wait. Okay. So I'm keeping current number. I'm keeping k, the current length, and current number of possibilities. While k is greater than the current number of possibilities, right? It's what I was doing here. I am subtracting the number of possibilities from k, because like I already said that I need to like, if I know that k has 2 digits, then I know that I want to subtract 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? I want to subtract each of these possibilities. Because now I will be wanting to find our kth number somewhere in here. So I need to subtract those 9 possibilities that I already like excluded or something. Okay. So what I am doing, while k is greater than the current number of possibilities, I am subtracting the current number of possibilities from k, and I am making my length greater. I'm also, well, multiplying by 9, because as I shown before, the number of possibilities is always 9 to the power of length. So now I know I have some length founded. I will say you in a minute why I am dividing by 9 here. I have found my current length, and I know that I want to find the kth number, but only considering the number of this length, the numbers of this length. So, how to do it? I'm building my answer from left to right. We are building the answer from left to right. Okay, so what are we doing? We are keeping our previous digit, because as I shown here, let's say that I already built the prefix 1, 3. Then I can't add 3 here. I can add 0, 1, 2, 4, 6, 5, 6, 7, 8 or 9 here. But I can't add 3 here. Right? So I'm keeping a previous digit. And what I'm doing? Well, if my number of possibilities is greater than the number of possibilities such that I have this prefix built, then this one j added here and then something here, then well, I need to subtract all these possibilities because they are like smaller. So I'm subtracting them, and otherwise, here is a little bit tricky part of code, I'm just adding this digit to the end of our number. Right? I know that the formula is like when I have some 13 and I am adding 4 here, it's like I would add 0 here. So multiply by 10 and then add this digit. So I'm multiplying by 10 and adding this digit. And I'm saying that my previous digit was here. Also, I am dividing by 9 here and here. Because, well, in my current variable, I would have... Here I would have the number of numbers, with length len, right? Or długość. But as I see, when I am adding my first digit, let's say that I have length 3 here. When I'm adding my first digit j here, I want to have the number of possibilities here, so it will be length 1 smaller. And also, if I added my 1 digit to prefix, the length will also get smaller. Someone wrote on the chat, BTV, I was able to solve B, but not A. My approach for B, we just need to know what is the maximum number of points that are collinear, which is a standard problem. Yeah, if someone wants to hurt B, I wasn't able to think of it on contest, but basically, in problem B, we had like some points on, points on 2D plane, and we want to construct the maximum number of triangles. So, for example, we could here construct this triangle and this triangle. So the answer would be 2. Every point can belong to at most 1 triangle. So I wasn't able to think of it, but basically the answer to this problem was minimum from n divided by 3, so maximal number of triangles, and from maximum number of points on 1. And from n minus maximum number of points on one maximum number of points on 1 line, you know? So this would be 1 line and this would be 1 line too. But I don't know how to prove it. So thank you for the stream. I promise that there will be someone better streaming next IRC, someone who can do more than 1 task during contest. So thank you and see you next time. Sorry for my incompetence.